We have now learned the elementary differentiation rule. We've learned the product rule and the quotient rule for differentiating functions. And now we're going to learn the chain rule. You can think of this rule as like links of chain, where we do one step and then the next step and then the next step, etc. At least that's where my brain goes. We're asked here, how do we find the derivative of something like this? You can see we've learned how to differentiate inside this function. We could do that, but yet there's an exponent now on this entire function. The chain rule answers this question. Okay, so the chain rule says that if you have a function f where one factor is to a certain power, you can differentiate it or find the derivative by, so here's the elementary chain rule. It's simply, we take the exponent, we bring it down in front, and then we put the original factor to the power of the exponent minus 1. That's just the elementary rule that we've learned back in 4.5, I think it was. Okay, that's the first part of the chain rule. That I would think of as the first link. The second part of the chain rule says that you take that and you multiply it by the derivative of this factor, or whatever in the brackets, whatever you are taking the exponent of. Okay, so let's give it a try. Like we did in 4.7, let's identify what we're dealing with here. We've got f, and that's just the 2x cubed minus 3x squared. And then we've got f prime, which would just mean we take the derivative of this. 3 times 2 is 6, to the power of 3 minus 1 is 2. 2 times negative 3 is negative 6, to the power of 2 minus 1 would be 1. Don't need to write it. Okay, so the chain rule says then, we have y prime. We're going to, first of all, take the exponent, or whatever we have up here, and move it down in front to be the coefficient. So in this case, we've got a 10, comes down in front. You can picture that coming down here. We are then multiplying the same original f, 2x cubed minus 3x squared, to the power of n minus 1. In this case, it was 10 minus 1, so 9. All multiplied by, then, the derivative of f, which we've calculated here. Okay, the chain rule. Now, we're going to do some work here to simplify that, but you can understand that. Now, this portion here, if that's something you don't want to do, it's not helpful to you, you certainly don't have to, but it does help to keep you organized and neat to understand where the original factor is and then the derivative of that factor. Okay, to simplify it here, we can take out a common factor from this last part. This 2x cubed minus 3x squared to the power of 9, that just needs to stay as it is. Okay, so y prime is equal to, there's a 10 out front, that's one factor. I can write it how it is here for this step. And then here we'll take out a common factor of 6x. That would leave x minus 1. Okay, let's put it there. Okay, so if we put terms together, 6 times, we could have 60x times x minus 1 times 2x cubed minus 3x squared to the power of 9. And that would be all you could do. That is the derivative of this function y. We're going to do this whole 4.8 in one part instead of two. So we're going to go through this quick. Number 2, I'm not sure why that one's there. Number 3, you can see the chain rule used here. Again, we've figured these two out, f and the derivative of f. Then the derivative of f of x, we take the exponent, take the exponent and bring it down in front, which is happening right here, and multiplied by the factor to the exponent minus 1, multiplied by the derivative of f. Okay, when you multiply those things together, it simplifies out to that answer there for that derivative. Number 4, we can see the chain rule being used here. So we, first of all, we look at this exponent, and we bring that exponent down in front. You can see that's going on right here. This is the coefficient, -2, times the exponent, multiplied by the original function, or f, factor f in the brackets there, all to the exponent -1, 5 minus 1, multiplied by the derivative of the inside of the brackets. And if we reduce that, our answer becomes minus 20. Okay, -2 times 5 times the 2 you factor out here, times x plus 3, x squared plus 6x minus 4, all to the power of 4. I'm going to skip over number 5. Same steps involved, and you can see the answer there if you want to do it on your own. You can turn over to page 16, and we'll go through a few of these examples as well. Okay, so f of x here, you can see is not written in the standard form we need with an exponent. So it's simple enough. We can rewrite that as 6 times 4x minus 3, changing this radical sign to an exponent of a half. Once that's done, we can see we've got highlighter. We've got here the function inside the brackets there. So again, if you want to write that down, that we call small f, and the derivative of that would be simply 4. So then if we use the chain rule says that the derivative of this will equal, so the coefficient 6 stays, we bring the exponent down in front to multiply by that coefficient. We leave this original f in brackets, and the exponent is the original exponent, subtract 1, in this case the denominator of 2, so we'll write 1 as 2 over 2, multiplied by, then, this is the second link in the chain, the way I think of it, multiplied by the derivative of f, which we've calculated there, which is 4. Okay, then we can simplify a few things here. We've got 6 times a half, which is 3, multiplied by 4, which is 12. And then here I can see this exponent is going to be a negative half. The negative makes that go into the denominator, and an exponent of a negative half. The negative brings it to the denominator. The half means square root. And there you have it. We're looking at number 2 now. Okay, let's write this function again. So we've got this written as an exponent. We've got the 9, 3x squared minus 1 to the power of 2, and this cube root we know can be written in the denominator of the exponent. Okay, that's good. Now let's use the chain rule to differentiate this function. First, we've got the coefficient 9, stays there, multiplied by the exponent, multiplied by the brackets. This is the first link of the chain. This is the elementary differentiation rule. Now to the exponent minus 1, we'll write 1 as 3 over 3, so the denominators are common. And then the second link of the chain, we multiply by the derivative of these brackets. So 2 down, 6x to the power of 2 minus 1, 1. Don't need to write it. Excellent. Okay, so then we can simplify this a bit. We've got 18 divided by 3, which would be 6, times this 6, 36x, and in brackets, 2 minus 3 would be a negative 1/3. So, because of this negative exponent here, we're going to write 36 over 3x squared minus 1, and the negative brought it to the denominator. The 3 means a cube root, and we're done. When we look at number 3, it looks like we could use the quotient rule, and we totally could. It would work out just fine. Let's apply the chain rule, though, since that's the section we're in. I can rewrite this function as being 2 multiplied by 5x minus 9 to the power of negative 1. Then when I want to differentiate that using the chain rule, I've got the coefficient of 2 multiplied by the exponent, multiplied by the function in the brackets there, the binomial I mean, to the power of the exponent minus 1, which would be minus 2, multiplied by the derivative of the binomial in the brackets, which would be 5. Then when I go to simplify that, 2 times negative 1 times 5 is negative 10, all divided by, this is because there's a negative exponent here, 5x minus 9, and it will be to the power of 2. Looks good. Okay, on to number 4. Okay, this function equals 8 multiplied by 6x squared plus 2, whoopsie, plus 2. Now, this was a negative exponent down in the denominator, and we see the square root, so that must to a negative half. Okay, derivative of this equals coefficient 8 times the negative half, exponent multiplied by 6x squared plus 2, all to the power of negative a half minus 1, negative 3 over 2, multiplied by the derivative of this binomial, which would be 12x to the power of 1. Sure.
Hello, everybody. I hope you're having fun on this question.
Okay, and then we simplify. 8 times negative a half would be negative 4, times 12 would be negative 48. X all over, because I know this is moving to the denominator because the negative exponent, 6x squared plus 2, and to the power of 3 over 2. We're going to leave it. This looks better than putting the square root sign around everything cubed. Good. And the last one, number 5. This function can be rewritten. It's really, wow, it looks big, but we can rewrite it pretty easily. 2x plus x to the power of a third. That's all under this square root sign, so we put brackets and represent the square root with the half. So then if we're going to use the chain rule to differentiate this, we've got no coefficient in front, so the exponent comes down, that's the half, multiplied by that binomial within the brackets, multiplied by the derivative within the brackets, so 2 times x to the power of 0, which is just 1, plus 1/3 comes down, x to the power of 1/3 minus 1, or, oops, sorry, 3/3. What's going on? Okay, and if we simplify that, then we've got, whoosh, it looks like a mess. And I forgot the exponent right here, which would be a half minus 1, which would be negative a half. Okay, so, well, we've got a 2 in the denominator, and this is in the denominator because of the negative half. We can rewrite that to the power of a half. This is in the numerator, 2 plus 1/3 x, 1/3 minus 2/3. Okay, let me pause this and we'll do the work and discuss it. Okay, I think we will leave it like that, even though there's a fraction there in that numerator. Ms. Cantillon had an omit by this question, so we're going to go with that. Okay, give these questions a try now. We're looking at numbers 1 through 27. If you would prefer, you can choose odd or even. Okay. Page 200.